Here is 1.682, continuing with transformations. So yesterday we learned all about the different types of transformations. So now we're going to go ahead and apply those transformations to the parent function and write the new function and then graph it out. So we're given a parent function of f of x equals x squared. Do we know what that visually looks like? What's the shape of it? We call it a U or parabola. So we focused on graphing these earlier in the chapter. So there is 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. Now we're going to apply the two transformations to it. The first thing is we want to move the graph, the blue graph, to the right 3 units. So that's on the horizontal axis. And we want to shift it up 4 units. So we're going to take this critical point of 0, 0, and now what is my new vertex going to be? What will be my new vertex after the transformations have occurred?
0, 0, 1.
Right
0,
3,
Oh.
and then up 4. So here's my new critical point. Did the shape change at all? No. So I still have the same 1 right, 1 up, 1 left, 1 up, 1 more right, and I'm up 4 from the critical point. So now there is my new parabola with the two transformations. The other thing we must do is go out and write that function. So let's talk about the two things. If I have a horizontal, that all stuff happens inside of the parentheses, inside of the function. And when I think those, I have to think always opposite. I either have to reciprocate if it's a scale factor, or I have to change the sign if it's a translation. So let's talk about what's going to go in here. What's going to be in there? We're talking horizontal. Very good. X minus 3. Then the second thing is the vertical. Anything on the vertical axis that changes is outside the function. So where is that plus 4 going to go?
Outside right.
Outside, right? Yeah. So now there is my equation. It's in what we call vertex form too, so we can quickly identify that vertex also when it's 3 and 4. A few minutes, just catch up there, and then we'll move on to the next example. Okay, next example. The parent function is in the blue. What is the shape of that parent function? What does that shape look like? The absolute value of x. We call that what shape? The V. So the critical point is 0, 0. And then we have 1, 1, 2, 2, 3, 3, 4, 4. If we go in the negative direction, we have negative 1, 1, negative 2, 2, negative 3, 3, etc. So there's the parent function. Now let's apply the transformations. One of the things it says is horizontally scaled by a factor of 2. So, how am I gonna do that? Yes, sir.
Is it 2 over x? 1 over x?
You're really close, yep. So remember, horizontal happens inside. So what do we have to do to that number to write it? Reciprocate? And then the other thing, it says reflect it about the x-axis. So where is my negative going to go?
Outside.
Outside, so on front here. Yep.
Would there be an f there?
No, because we changed the original function is the parent function f of x and then be g of x.
Oh.
All right, so let's go ahead and graph it with the transformations. So one of the things is we have to transform it by reflecting about the x-axis. So let's do that first.
Yeah, write this down.
Sure can. Okay, I'll just go to green and take care of this first. So I go along the x-axis. I'm going to imagine folding the piece of paper along that x-axis. Where's my critical point going to go? Still at 0, 0. And now imagine where's 1, 1 going to go?
1 negative 1?
1, negative 1,
Negative 1.
negative 1. And we just continue this pattern. So there's with one transformation, but that's not our final answer. We have to change the horizontal axis values, so the x values, by a scale factor of 2. So if I think about this point right here, negative, a positive 1, negative 1, and I need to change that number, the x value, by 2. What's the new order pair going to be? I'm changing the x value by multiplying it by 2.
2 negative
It's going to be 2 and then negative 1. So there will be my first point. Now will I have the same over here then? Yep. Because these are symmetric, so it's going to be negative 2. And then if I think about this value was to negative 2, and I'm changing that x value by 2, what's that next value going to be? Multiply the x value by 2, so 4, negative 2. Okay, now we can just kind of go on from there. And there is my red g of x function applying the 2 transformations. I tend to do my reflections first, and then my shift changes left and right, and then I do my scale factors last. Ooh, this is a big one. Maybe we'll stop at that one and we'll pick back up again with a new movie.